Imagine standing at the edge of time itself. Not looking across an ocean or over a mountain range, but gazing into a darkness so deep that every point of light becomes a message from the distant past. In astronomy, looking farther into space means looking farther back in time. Because light travels at a finite speed, the images captured by our telescopes are not showing the universe as it is today, they are showing it as it once was. Some of the light reaching Earth tonight began its journey billions of years ago, long before our planet existed. Those ancient photons have crossed unimaginable distances to tell a story that has remained hidden for most of human history. To uncover that story, humanity built one of the most advanced scientific instruments ever created, the James Webb Space Telescope. Launched into space to observe the cosmos with unprecedented sensitivity, Webb was designed to see farther than any telescope before it. Its mission was simple in concept but extraordinary in scale: to study the earliest chapters of cosmic history and reveal how the first stars and galaxies emerged from the darkness that followed the birth of the universe. Scientists expected Webb to confirm many of the ideas that modern cosmology had developed over decades. Instead, it began revealing surprises. And some of those surprises are forcing researchers to rethink what they know about the early universe. According to the standard cosmological model, the universe began approximately 13.8 billion years ago in an event known as the Big Bang. During the first moments, the cosmos was unimaginably hot and dense. As space expanded, temperatures dropped, allowing particles to form and eventually combine into simple atoms. Hydrogen and helium became the dominant ingredients of the young universe. Yet despite the presence of matter, there were no stars, no planets, and no galaxies. Astronomers call this era the cosmic dark ages. For millions of years, the universe was filled with gas but lacked visible sources of light. Gravity slowly began pulling matter together. Tiny fluctuations in density grew larger and larger until immense clouds collapsed under their own weight. The first stars ignited. Their light pierced the darkness for the first time. These stars then gathered into the earliest galaxies, beginning a long process of cosmic evolution that would eventually lead to the rich and complex universe we observe today. At least, that was the expectation. The deeper astronomers looked into the past, the simpler everything should have appeared. Early galaxies were expected to be small, chaotic, and poorly organized. Large structures and complex systems were thought to require billions of years to develop. But when Webb began examining the most distant reaches of space, something unexpected appeared. Instead of finding only primitive galaxies, researchers discovered objects that looked surprisingly mature. Some displayed organized structures. Others appeared larger and brighter than predicted. A few even showed characteristics normally associated with galaxies much closer to our own era. These observations immediately attracted attention because they seemed to conflict with existing models. How could galaxies become so developed so quickly? To understand the significance of this question, imagine discovering a modern city in a location where only the first foundations of civilization should exist. The existence of such a city would force historians to reconsider their timeline. In a similar way, these ancient galaxies appeared to be evolving faster than expected. At first, scientists wondered whether the distances had been miscalculated. Astronomers determine extreme distances using a phenomenon called redshift. As the universe expands, light stretches toward longer wavelengths. By measuring this stretching, researchers can estimate how far away an object is and how long its light has been traveling. Repeated observations, however, continued to support the original findings. Many of these galaxies truly seem to exist only a few 100 million years after the Big Bang. That may sound like a long time, but on cosmic timescales it is remarkably early. The surprises did not end there. Webb also allowed astronomers to analyze the chemical fingerprints hidden within ancient starlight. Every element leaves a unique signature in the light it emits or absorbs. By studying those signatures, researchers can determine what distant galaxies are made of. What they found raised even more questions. Several early galaxies appeared to contain significant quantities of heavier elements such as carbon, oxygen, nitrogen, and iron. This is important because the Big Bang did not create large amounts of these elements. They are forged inside stars through nuclear fusion and later scattered into space when stars die. For heavy elements to exist, stars must first be born, live their lives, and then explode or shed material into the surrounding environment. The presence of these elements suggests that stellar evolution may have occurred much faster than expected in the young universe. In other words, generations of stars may have formed and died in rapid succession, enriching space with complex chemistry far earlier than existing theories predicted. Then there are the black holes. Among the most mysterious objects in the universe, black holes possess gravitational fields so intense that not even light can escape once it crosses a critical boundary. Particularly puzzling are supermassive black holes, which can contain millions or even billions of times the mass of our Sun. Conventional models suggest that such enormous objects should require long periods of growth. Yet Webb has detected evidence of massive black holes existing surprisingly early in cosmic history. Their presence creates a difficult question. How did they become so large so quickly? Scientists are currently exploring multiple possibilities. Some theories propose that enormous clouds of matter may have collapsed directly into giant black holes during the universe's infancy. Others investigate whether unknown physical processes accelerated their growth. At present, there is no definitive answer. Dark matter adds another layer to the mystery. Although it cannot be observed directly, dark matter appears to account for most of the matter in the universe. Its existence is inferred through its gravitational influence on visible objects. For decades, scientists have believed dark matter played a crucial role in building the cosmic web of galaxies and galaxy clusters. However, Webb's discoveries are encouraging researchers to examine whether dark matter's influence in the early universe was even greater than previously imagined. Could it have helped organize matter more efficiently? Could it have accelerated the formation of structures? These questions remain open. Perhaps one of the most fascinating discoveries involves chemistry associated with life itself. Using its powerful instruments, Webb has detected complex carbon-containing molecules in distant regions of space. These compounds are considered important ingredients in the processes that can eventually lead to biological chemistry. The significance of this finding extends far beyond astronomy. It suggests that some of the essential building blocks of life may be widespread throughout the cosmos. Rather than being unique to Earth, the ingredients necessary for life's chemistry may have been present across the universe for billions of years. This possibility transforms one of humanity's oldest questions. If the components of life are common, could life itself also be common? For now, nobody knows. What Webb continues to reveal is that the universe is often more complex than our models predict. Every new observation expands our knowledge while simultaneously exposing new mysteries. Galaxies appear earlier. Structures seem more organized. Black holes grow faster. Chemical complexity emerges sooner. Instead of simplifying the story of cosmic history, the James Webb Space Telescope is making that story richer, deeper, and more intriguing. Perhaps that is how science advances. Not by proving that we already understand everything, but by showing us where our understanding is incomplete. Every image captured by Webb represents light that has traveled across billions of years of cosmic history. Those photons began their journey before Earth formed, before oceans existed, and before any living creature looked toward the stars. Now they arrive at our instruments carrying information from a time almost beyond imagination. And with every new discovery, one truth becomes increasingly clear. The universe is still holding many of its secrets. The deeper we look into the cosmos, the more extraordinary and mysterious the story becomes.